Hey guys, welcome back to Max MEDC with Ebi, where all of the concepts are explained in detail. So we were looking on statistics, so we'll continue with that. In the previous video, we saw about the definition for measures of central tendency, which is nothing but average. Average is a single value which denotes a large number of observations, and you have 5 ways to denote an average. So that's arithmetic mean, geometric mean, harmonic mean, median, and mode. And in your book they have discussed only arithmetic mean, median, and mode. So for the subscribers, I have given them a surprise as an inclusion for geometric mean and harmonic mean, so do subscribe if you have not. So today we shall go with methods to find arithmetic mean, and in that method we'll go on with direct formula method and assumed mean method for by considering time. So what do you mean by frequency? Frequency is nothing but number of times number of times an observation occurs is called as a frequency. So if the frequency is not given, it is assumed that frequency is equal to 1, and you have two methods to find the arithmetic mean when the frequency is not given. So the direct formula method and the assumed mean method. In the direct formula method, you sum all the observations and you divide it by n, and in assumed mean method you assume a mean freely from the given observations, and with that assumed mean you calculate the deviations from the observations and then find the mean by using the given formula. Right, so we'll get on with problems describing how to find arithmetic mean. But in general, we denote arithmetic mean as x bar, and x bar is nothing but the sum of all observations divided by n, or to be said mathematically, it's summation running over x divided by n. So x1, x2, x3 up and so on up to xn are nothing but n observations, and n is the number of observations. So let's get started with the problem. A cricketer played 8 T20 matches and scored the following scores. So we are given 8 scores, that is 25, 32, 36, 38, 45, 41, 35 and 36. We are supposed to find the arithmetic mean of the given scores. So as said, arithmetic mean is nothing but the sum of observations over the number of observations. So the sum of observations is 25 plus 32 plus 36 plus 38 plus 45 plus 41 plus 35 plus 36, which is nothing but 288, over the number of matches he played is 8. So 288 over 8 gives you 36. So what does this 36 mean? This 36 means the average value or the average score he scored in each of the matches. So if someone asks the cricketer how many scores you have scored in each matches, so he could say as a single value that I have scored an average of 36 runs in all matches. So instead of saying all the 8 values, he just have a single value to say. So that is called as an average. Let's check whether all the observations are around average. So while defining average, I said that the average value is surrounded by all the other values. So let's check whether it's true or not. So 25 is nearer to 36 by 11 values. 32 and 36 are nearer by 4 values. 36 and 36 both are same. 38 and 36 are nearer by plus 2. 45 and 36 are near by 9 values. 41 and 36 are by plus 5 values. 35, 36 minus 1, 36, 36 the same number. So we just note that each and every value in the observation is nearly plus or minus 10. So all the observations comes around the average value. So what I said was true, and the truth of the statement was proved here. So to conclude, on an average, the cricketer mentioned scored 36 runs in each matches. And I know that summing 25, 32, 36, 38, 45, 41, 35, 36 could be a huge task by time consume. It's actually time consuming. So in the next method, I freely assume a mean called A, that is the assumed mean, and now I find the of deviations of each of observations from this assumed mean, right? So the observations given are 25, 32, 36, 38, 45, 41, 35, and 36. I assume A to be 38. To be very frank, I can choose any of the given observations here, but you have to guess the average value here. So I guess the average value to be 38, or some choose the assumed mean to be the middle value. That's also acceptable. So for now I take the assumed mean to be 38. I find the difference of the assumed mean from the observations. So it's like 25 minus 38. 25 minus 38 equals minus 13. 32 minus 38 is minus 6. 36 minus 38 equals minus 2. 38 minus 38, of course, the same value gives you 0. 45 minus 38 gives you 7. 41 minus 38 gives you 3. 35 minus 38 gives you minus 3. 36 minus 38 gives you minus 2. So now I sum all these deviations, right? I get minus 69 and I apply this in the formula. So how did this formula come? Maybe in the upcoming videos I will be uploading it. So x bar equals a plus summation d over n, where d is x minus a. So for now the assumed mean value is 38 and summation d is minus 16 over the number of observations is 8. So 38 minus 36 divided by 8 gives you 38 minus 2, which in turn gives you 36. So note that irrespective of the method you use to find the arithmetic mean, you get the same value. So you could choose any method to find the arithmetic mean of a set of observations. So again, in an average, the cricketer scored 36 runs in each matches. Here we saw a different method, and in the previous problem we saw a different method, but we arrive at the same answer. So let's stop up to this. In the upcoming video, I will be discussing the calculation of arithmetic mean when frequency is given. Until then, take care, bye bye, see you in the next video.